In this lesson, we are going to go over the triangle midsegment theorem. The triangle midsegment theorem, T44, says, a midsegment of a triangle is parallel to a side of a triangle, so one side of that triangle, and its length is half the length of that side. But what exactly is a midsegment? So a midsegment is a segment whose endpoints are the midpoints of the other two sides. So x is the midpoint of AB, and y is the midpoint of BC. So a midsegment of a triangle is parallel to a side of a triangle, and its length is half the length of that side. So in other words, this theorem says if x and y are midpoints of AB and CB respectively, then xy is parallel to AC, and xy is also equal to 1/2 AC, so half the length of that side. Let's go ahead and prove the triangle midsegment theorem. Well, let's start with what's given. We know that x is a midpoint of AB, and we also know that y is the midpoint of CB. But what exactly does midpoint mean? A midpoint divides a segment directly in half. So that means that AX is going to be congruent to XB, and CY is going to be congruent to YB. And since it divides it directly in half, we know that those are equal. We can also say by the segment addition postulate that AX plus XB is equal to segment AB, and CY plus YB is equal to segment CB. Now let's go ahead and use substitution and substitute XB in for AX, as well as YB in for CY, since AX equals XB and CY equals YB. And from there, we can simplify. XB plus XB is equal to 2XB, YB plus YB is equal to 2YB. From the equations in step 5, we have that XB is related to AB, and YB is related to CB, so let's manipulate those to show that they're proportional. So if we divide this equation, both sides by AB, we have that 2XB over AB equals 1, and if we divide this equation, both sides by CB, we have that 2YB over CB equals 1. And that's by multiplication and division properties. And since both of those equal 1, we can substitute 2YB over CB into 1 in the first equation to get that 2XB over AB equals 2YB over CB. And you can see if we multiply both sides by 1/2, the 2's would cancel out on each side of the equation, leaving us with XB over AB equal to YB over CB. So XB over AB equals YB over CB, and that's by multiplication and division properties. So we have in the triangle XB over AB equals YB over YC, and we know that angle B is congruent to angle B. That's by the reflexive property. That will be our step 9, and then that will allow us to use the side angle side similarity theorem to show that triangle XBY is similar to triangle ABC. And from this point, just like in the last theorem we proved, T43, the converse of the triangle proportionality theorem, since XBY is similar to ABC, we can say that angle X, and this angle X is meaning this angle BXY, so angle X in this smaller triangle is congruent to angle A. And from there, since AB is a transversal of both XY and AC, and the corresponding angles are congruent, we're going to be able to say that XY is parallel to segment AC. So back down to our proof. So XY is parallel to AC by the converse of the corresponding angles postulate. Now, remembering our theorem, we needed to prove not only that XY was parallel to AC, which we've done now, we also need to prove that XY equals 1/2 of AC. But let's go back to an equation that we've already developed. In step 5, we said that 2xb equals AB and 2yb equals CB. So let's divide both sides of the first and second equation by 2. So we're going to have that xb equals 1/2 of AB and yb equals 1/2 of CB by the multiplication and division properties. Remember that we were able to show that triangle XBY was proportional to triangle ABC. So if XB is equal to 1/2 of AB and YB is equal to 1/2 of CB, and all the sides of similar triangles are proportional, then we're going to be able to say that XY is equal to 1/2 of AC. So now we have XY equals 1/2 of AC, and that's by the definition of similar polygons, because polygons that are similar have proportional sides. So we showed in 12 that XY was parallel to AC, and we showed that XY was equal to 1/2 of AC. And that is what we needed to prove. That X and Y were midpoints of AB and CB respectively, then XY was parallel to AC, and XY was equal to 1/2 of AC. Corollary 6, C6, says that if 3 or more parallel lines divide off congruent segments on one transversal, so these 3 parallel lines divide off or separate congruent segments. So that's saying that AC is congruent to CE. So they divide off congruent segments on one transversal. Then they divide off congruent segments on other transversals. So now BD is congruent to DF.